Hello students, this video is about even and odd functions, and in it we are going to first talk about just about reading graphs and then how to tell if a function is even or odd from the graph and from the equation itself. So first of all, when you're looking at graphs, you always want to read them from left to right. So I know you see this arrow going down and you're like, oh, I'll just slide down, the function's going down. But no, you want to start on the left and move to the right. So you can see that the function from left to right is actually increasing until it gets to here, until it gets to 1. And then from 1, it starts going down, decreasing until it gets to 3. And then the function is constant or flat from 3 to infinity. So make sure you read that left to right. Now, the functions can also have relative maximum and minimum points. Now, that is the highest and lowest point within a range of values. So it doesn't have to be the overall highest, but if I just consider the range between my fingers, if this is the lowest value I'm considering and this is the highest value I'm considering, then in between my hands I do have a maximum. It's a relative maximum right here at -1. Okay, I have a relative maximum. It's not the overall maximum of the function, is it? Because the function gets higher over here. But even so, this is considered a relative max. And here I have a relative min at +1. So I have a relative min. It's not the minimum of the entire function, is it? Because the function continues to go down, and I have this arrow here. The function will continue to go down and down and down. So the function does not have a overall minimum point, but I have a relative min here. So I have a relative max at -1. And the relative max, if I plug in -1, it looks like it comes all the way up to 2. My relative max is 2. And then I have a relative minimum at x is +1. And I can see that at 1, the function is coming up to about 1/2. All right, so how can you tell if a function is even or odd? Well, if you're going to try to check to see if it's even or odd, you should replace the x with -x and see what you get. And you can also tell if it's even or odd by looking for symmetry in the graph. Even functions. If you have an even function and you plug a -x into the function, what you get is the same function back. F of -x equals f of +x. When you replace x with -x, the function stays the same. The graph of an even function is symmetrical across the y-axis. So for example, if you look at the graph of y equals x squared, it's an even function because this half of the graph is an exact mirror image of the other side of the graph. So since you could have a mirror line, a reflection line right across the y-axis, that's how you know the graph is of an even function. Okay. Now another way that you can tell it's even, or at least a clue to being even, is the fact that the exponent here was even. So x squared, when the degree is even, it can give you a even function. Okay. Another example might be something like this. If you were to have a reflection line right in the middle, this half is exactly symmetrical to the other half. You could reflect it. Now, just because the degree is even does not mean that it's going to be an even function, because it could be off of center. So let's just put not always. Okay? You can't just see that it has an even degree and say, oh, it's going to be an even function. But if the highest exponent is even, then either it's going to be even or it's going to be neither. So, okay, we're going to see that in our example. All right, so now odd. Odd functions. If you have f of -x, that equals -f of x. What that means is that if you replace x with -x, what you get is the same function, but it's changed signs. All of the negatives have become positive and the positives have become negative. Okay, so if you had a positive, it becomes negative. If you had a negative, it becomes positive. Now, the graph of an odd function is rotationally symmetrical. There's 180 degrees rotational symmetry. Another way of saying that the graph has 180 degrees rotational symmetry is to say that the graph is symmetric with respect to the origin. So if you look at the graph of x cubed, which I have right here, if you look at this graph and you were to take it and you were to flip it upside down, you get the same graph back. That's what it means to be odd. So here is the same as here. Okay, the same thing with cosine. Cosine is also an odd function, because if you take the graph of cosine, okay, and you flip it upside down, you get the same thing back again. So cosine is another odd function. Cool. Okay, let's look at some examples. For each one of these examples, I have 3 examples. We're going to see if we can identify whether or not it's an even or odd function, state the relative max and min, and describe the increasing and decreasing trends that we see in the graph. So for this first function, x cubed minus 6x, let's start off by taking this and replacing x with negative x. Okay, so what is negative x cubed? Negative x cubed means negative x times negative x times negative x. So I'm going to have 3 x's and also 3 negatives multiplied together. Well, I know that negative times negative, 2 negatives together, make a positive. So when I multiply 3 negatives together, 2 of them make a positive, and I have 1 negative left over. So negative x cubed is negative x. Okay, here I have a negative 6 times negative x. Negative times negative cancels out to give me plus 6. Okay, now we compare this to the original one, and it looks like the only difference is that the signs have changed. Before, the x cubed was positive, now it's negative. This was negative, now it's positive. So since all of the signs changed, I know that this is an odd function. Okay, now I take this original function and I graph it in my calculator, and I'm going to use my calculator to find out where my relative maximum and minimum points are. Okay, so it looks like I have a relative max at negative 1.4 and a relative min at positive 1.4. All right, where is the graph increasing? Well, it looks like it's increasing on this first stretch right here. So if it's increasing right here, it's going up. And then during this interval here, the graph is headed back down. And then from this point forward, the graph is increasing again. It's increasing from negative infinity all the way to this point, which is at negative 1.4. And the graph is also increasing from positive 1.4 to infinity. It's decreasing between these 2 points, so between negative 1.4 and positive 1.4. This time, let's replace x with negative x and see what we get. Well, when I have 4 negatives, 2 of the negatives are going to cancel out to make a positive, and the other 2 negatives are also going to cancel out to make a positive. So negative x to the 4th is just positive x to the 4th. All right, and the same thing happens with negative x squared. Negative x squared, well, negative and negative, that makes positive. So I compare this to the original, and it looks like it stayed exactly the same. Since it stayed the same, I know that the function is even. Now I take this original function and I graph it on my calculator. So it looks like I have one relative max, a relative maximum right here at 0. And I have a relative minimum, I have 2 relative minimums at negative 1 and at positive 1. Now, where is the function increasing and decreasing? The first interval of increasing is from negative 1 to 0. And then it also increases from positive 1 to infinity. And the function decreases from negative infinity to a negative 1 and from 0 to positive 1. Let's look at this last example. When I look at this, I think to myself, oh, it's going to be even function, right? Because it has an x squared in it. This one had an x fourth, and 4 is an even number, so it was an even function. Let's see what happens here when I replace x with negative x. Negative x squared gives me positive x squared. 2 times negative x gives me negative 2x. And we still have the 1. So, only one of the signs changed, while the other two stayed the same. Since they did not all stay the same, or they didn't all change, this function is neither even nor odd. And if you look at the graph, that confirms this, right? Because this graph is not symmetrical around the y-axis. Now it is symmetrical right here around this point, around x equals negative 1. It is symmetrical, but that is not the y-axis. It would have to be symmetrical around the y-axis in order to be even. So this point occurs at negative 1, 3, and that will be our relative max, or relative minimum. And actually that's just the overall minimum, isn't it? In the max, there is no max. It just goes on and on. All right.